Dah masuk?
Okay, Assalamualaikum warahmatullahi wabarakatuh. And every good afternoon. So kita dah boleh start So ni saya akan offkan. Semua dah makan dah? Minggu depan puasa kan? Ni satu lagi. Minggu depan dah puasa. Okay, nampak Okay, just untuk apa kata refresh, last week punya chapter is chapter 2 is about the material for manufacturing. We have already covered about the steel and also the iron lah. Okay, it means iron plus carbon is equal to steel. So today we will sorry huruf kecil apa tu? Tolong buka attendance lagi boleh tak? Nantilah masa kita masa kita ada initial break ke kan, dalam 5 minit sebelum kita quiz, saya akan buka balik yang yang QR code tu. Okay, hari ni dalam 2.55 kita akan berehat, berehatkan mata semua, and then dalam pukul 3 saya nak you all buka Ulearn and then jawab quiz dalam masa 10 minit, and then kita akan sambung kuliah. Okay, so that this is the chapter 3 and net shape processes. What is net shape? Net shape means shape yang akhir lah. Okay, this is the content for today. The about introduction about the net shape, and then the type of net shape processes, and then kita pergi kepada expandable mold, which is there is a 3 type of expandable mold, called sand casting, investment casting, and also the loss form. Okay, and then we go to the permanent mold. Expandable mold ni maksudnya mold yang boleh diubah lah. Permanent mold maksudnya mold yang kita tak boleh mold yang memang kita tak boleh ubah lah. Maksudnya kalau kita dah pakai je lah. Kalau expandable mold ni kita boleh pakai berulang kali. Okay, this is the introduction. What is the net shape product? The near net shape refers to an industrial manufacturing technique where the initial production of the item is very close to the final ataupun net shape. Okay, reducing the need for surface finishing. Okay, maksudnya ni adalah satu teknik manufacturing yang mana kita produce the item tu very close dengan the final product yang kita nak. Which mean the final product yang kita nak biasanya adalah dalam bentuk yang kita lukis lah dalam SolidWorks ke ataupun dalam AutoCAD ke, yang mana kita nak, with the dimensions lah. Which mean the dimension is close to the dimension yang awak design. And then net shape net shape product ni juga adalah satu produk yang bila kita dah kita dah potong produk tu, dengan kata lain kita dah potong ataupun kita tak memerlukan the post processing, which mean the post processing maksudnya kita nak grind dia, kita nak groundkan dia untuk bagi dia surface finish dia tu smooth. Maksudnya tak ada yang kasar-kasar lah, tak ada ber semua tu bila kat tepi-tepi produk tu. And then reducing the traditional finishing such as machining or grinding eliminates more than 2/3 of the production cost in some industries. So that the net shape product ni tujuan dia salah satu untuk eliminate the cost. Okay, which mean kita eliminate the cost by reducing the post processing. Which mean kita tak perlu nak finishing lagi lah selepas kita machine. This is the process of the net shape processes, including the casting, forging, and also the injection molding. Okay, this is the advantages of the net shape processes. Able to get the net shape or near net shape product due to molten metal can flow. Ingat molten material yang last week yang kita belajar, molten metal can flow into the very small section to intricate shape can be made by this process. Maksudnya ini adalah molten flow yang iron ataupun yang steel tadi, kita masukkan ke dalam mold, and then dia akan jadikan net shape process lah. And then mold adalah acuan. So kita buat kek tu kan, you masukkan dalam acuan-acuan so that dia punya produk semua sama lah. Okay. And then as a result, many other operations such as machining, forging, and welding can be minimized. Okay. Ni maksudnya ni adalah post processing lah. And then the second advantage is possible to cast practically any material, either the ferrous and also non-ferrous. Last week kita dah tengok what is the ferrous, what is the non-ferrous. And then the necessary tools required for casting mold are very simple and inexpensive. And then as a result, for production of a small lot, it is a ideal process. And then last but not least, the advantages is size and weight of the product is not a limitation for the casting process. Basically, the new net shape process ni dalam syllabus ni adalah by casting, via the casting, ataupun penuangan. But if some have advantages, there also have a disadvantages or the limitation, okay, ataupun constraint, which is the limitation is dimensional accuracy and the finish of the casting depends on type of the process, okay, and then low in sand casting and high in other processes. The basic casting is using the sand casting, which means our mold is made from sand, from pasir. But then the limitation is the dimensional accuracy is not accurate lah. Maksudnya kalau kata you nak 10 mm, mungkin bila you buat sand casting tak dapat 10 mm dimension dia, mungkin dapat 9 mm. And then the metal casting is a labor intensive process. Okay. And then is there any automation for the casting? Kita still tak ada automation lagi. Okay, this is the fundamental of the metal casting. Ini kalau tengok ini adalah casting lah. Ini adalah you punya mold. Ini adalah you punya mold. Ini you punya untuk tuang-tuang tu lah. Nanti kita tengok. Okay, this is the how to make this engine block. This engine block sebenarnya dibuat daripada casting. Very complex shape kan. Dia boleh buat menggunakan casting. Okay. This is some example of the product of the casting, the engine blocks, this one, and then the crankshaft, automotive component, plumbing fixture, office equipment, etc. Kebanyakannya dalam otomotif adalah by the product is made of the casting. Okay. Okay, what is the metal casting? This is the definition of the metal casting. The casting process basically involves of pouring molten metal into the mold pattern after the part to be manufactured. Okay, inilah casting. Ni kita punya molten metal, kita pour ke dalam what we call pattern. Okay, ini kita nanti kita akan tengoklah what is pattern, what is the mold. Okay, and then allowing it to solidify. Lepas kita dah pourkan dalam pattern ni, and then apa kata dalam mold ni, and then that molten metal akan solidify, akan keras lah. And then removing the part from the mold. And then kita akan buangkan part lah. Ni kita buangkan part ni. So that dapatlah kita punya casting product. Okay. This is the the three general process of the metal casting. Pouring, and then solidifying, and then also the removing. Okay, the parts. Okay. Okay, this is the gating system for the casting. Okay, this is the ready. Ni contoh yang ni lah tadi. Contoh yang ni tadi. Tapi produk lain lah. Tapi ni dia punya gating system. Gating system untuk kita masukkan, kita tuangkan molten metal tadi. This is the pouring basin lah. Maksudnya kita tuangkan molten metal tadi kat sini. And then dia akan pergi kepada sini lah. And then dia ada ingot chop. Dia ada chop kat sini. And then dia ada blind riser dekat sini. And then ni kita panggil runner, ni kita panggil runner, yang ni kita panggil screw. Lepas ni kita akan tengoklah definition satu-satu. Yang ni ini adalah main cavity. Main cavity which mean the the product tadi lah yang kita nak. Produk ni sebenarnya bentuk ni lah. Ni adalah open riser. Ini lebih kepada untuk kita buangkan udara-udara yang terlebih so that produk kita ni takkan ada bubble. This is the vent. And then this is the parting line. Maksudnya dia ada perempuan dan betina lah dekat sini. Dia ada the top, dia ada bottom. And then this is the core. Maksudnya produk ni nanti akan ada lubang. Ni core ni. Ni dia chaplet. Chaplet ni adalah untuk supporting the core. Kalau kita tak ada pin ataupun nama dia chaplet ni, so that core tu akan bending akan terbend macam ni ke. Kita nak ada static ni. So that kita kena support by the chaplet. Okay. Okay, this is the important consideration in casting operation are as follows. Flow the molten metal into the molten liquid. Ini tadilah yang saya cakap tadi. After the molten metal is poured into the polymer mold, a series of events takes place during the solidification of the metal and its cooling to ambient temperature. Okay, this event really influence the size, shape, uniformity, and chemical composition of the grain formed throughout the casting, which in turn influence its overall properties. Which mean during the solidification, during the solidification, during the keras tu, there are some series of the process, which mean that process influence the size, the shape, uniformity of the product, also the chemical composition, and then which in turn dia akan influence the overall properties lah of the product. Okay, it means the properties mean the mechanical properties, basically the mechanical properties. Okay. Okay, ini tadilah gambar paling depan sekali tu kan. Ini adalah schematic illustration of a typical riser gate casting. A riser also known as a feeder. Okay, mana riser? Okay, ni, this one. Feeder maksudnya tempat kita nak fitkan the molten metal. And it's a reservoir built into a metal casting mold to prevent cavity due to shrinkage. Okay. And then most metal, sorry, the riser ni dia sebenarnya adalah silap. Itu adalah pouring cup. Pouring cup ni adalah untuk kita apa kata pour the molten metal. But then the riser ni adalah feeder ataupun dia adalah reservoir yang dibuat untuk apa kata prevent the cavities due to shrinkage. Maksudnya nak prevent adanya cavities. Adanya cavities tu adanya apa kata pour lah kalau kita punya produk. Sebab bila solidification, so that kita akan ada kita punya tu akan shrinkage lah. Okay. And then most metal are less dense as a liquid. Then as a liquid, so casting shrink open cooling. Masa nak cooling tu, casting kita tu akan shrink. Which can leave a void. A void ataupun pore tadi at the last point of to the solidified. Riser prevent this by providing molten metal to the casting as it solidified. So that the cavity forms in the riser and not the casting. So that the casting tadi, riser ni lebih kepada instead of the cavity tadi form into the apa kata the casting product, it will form in the riser. Okay, this is the purpose of the riser. Okay. Okay, this is the solidification of the pure metal. Kita ada dua. Yang A ni adalah temperature versus time for the solidification of pure metal. Note that the freezing takes place at a constant temperature, and then the B is density, function of the time. Kalau kita tengok daripada solidification punya phases ni metal, metal solidification. This is the temperature. Daripada temperature tinggi tadi dalam bentuk liquid, dia pergi pada A, and then daripada A ke B ni temperature dia adalah this is the solidification temperature. Maksudnya setiap material dia ada dia punya solidification temperature dia. Maksudnya temperature yang daripada cair, temperature untuk dia keras. So that during this A dan B ni, the temperature of solidification is fixed lah. Which means the phase is mix of liquid and also the solid. And then at B, until the end, is the cooling phases ataupun cooling of the solid. This is the solidification end. So that dekat sini adalah solid. Okay. And then it's vice versa to the specific gravity. Specific gravity which mean the apa kata bila kita sebut specific tu maksudnya kita bahagikan dengan density. Okay. So that kalau kita tengok kat sini, this is the shrinkage of the solid, of the liquid by time. So that yang ni dia akan by time ni, dia akan bila time fix ni dia punya specific gravity dia makin tinggi lah. So that yang ni dia shrinkage of the solid. Okay. Okay, this is the some theoretical equation for the fluid flow and solidification time. Which mean the sprue design, mana tadi sprue? Okay, this one the sprue design ni adalah dia punya apa kata equation lah. A equal to area, H is the height of the sprue. Okay, and then this is the Reynolds number, and then this is the, ni saya tak pergi detail and then this is the macam mana sebut Voronov rules. This is the solidification time lah. Volume bahagi surface area. C ni adalah fixed coefficient of friction, and also the N. Two basic principles of fluid flow are relevant to getting design is Bernoulli theorem and also the law of mass continuity. Hope you dah belajar ni lah mekanik ke belum? Kalau you dah belajar fluid mekanik, you tahulah. Kalau you tak belajar, nanti you akan dapat lah. You akan nampak this equation dalam fluid mekanik. Okay. Dah belajar tak fluid mekanik?
Belum, Doktor.
Okay, kalau tak belajar lagi, tak apalah. Yang ni just saya tak nak terangkan. So maksudnya apa kata, yang ni just apa kata you punya pengetahuan je lah. Untuk fluid mekanik, biasanya kita ada Bernoulli theorem dan juga law of mass continuity.
Belum, Doktor, belum.
Okay, maksudnya yang ni, contoh yang ni kita punya ni kan. So that pressure dekat sini lebih besar daripada pressure dekat sini dan lebih besar daripada, maksudnya pressure dekat sini lebih kecil, ini kurang kecil, macam ni saya nak ni. Okay, maksudnya pressure dekat sini macam ni okay, dia maksudnya pressure sini lebih besar daripada pressure sini dan lebih besar daripada pressure di sini. This is the law of mass continuity. Any fluid moving through a pipe obey the law of continuity, which says that the product of average velocity, pipe cross-sectional area, and the fluid density for a given flow stream must remain the constant. Maksudnya any speed okay, velocity to speed lah. Any speed, any area dekat sini walaupun area dan juga speed dia berbeza, this Q is remain the same. Okay. Which mean kalau kata di sini area ni kecil, so that speed dia sepatutnya tinggi lah. Kan? Kalau ini area dia besar, speed dia rendah. Ini secara apa kata, secara praktikal, secara bukan secara teori lah, secara apa logik pun dapat tahu kot. Ini kalau area dia lagi besar, velocity dia lagi kecil. Okay? Ni kalau ni velocity dia besar tapi area dia kecil. Kan? Jadi ini secara apa kata, secara logik lah. Kalau sesuatu permukaan, kalau air tu kan, awak lalukan air dekat satu tube yang kecil, cepat je kan dia mengalir kan. Kalau dekat tube yang besar, dia slow je. But then the mass continuity dia is still the same. Yang ni saya tak pergi jauh sebab you tak belajar lagi. Okay, this is the fluid flow molding casting. Dia ada lagi tak? Tak ada. The capability of the molten metal to fill the mold cavity is called the fluidity. Fluidity is mean the capability, maksudnya keupayaan lah that molten metal tadi untuk memenuhi this cavity. Cavity ni ataupun kita punya produk yang kita nak lah. And then which consists of two basic factors, characteristic of the molten metal ataupun casting parameter. Ini adalah contoh, ini adalah test method for fluidity using the spiral mold. Kalau tengok ini adalah macam ubat nyamuk zaman-zaman tahun 80-an 90-an lah. The fluidity index is the length of the solidified metal. Ini adalah test of the solidity. Maksudnya ni adalah pouring cup, you masukkan molten metal dalam ni. And then kita tengoklah dia punya, this is kita anggapkan adalah cavity. Kita tengok this molten metal ni dia akan memenuhi this cavity. Okay. And then dia punya apa kata, measurement dia adalah by the fluidity index. Fluidity index is the length of the solidified metal in the spiral passage. So that maksudnya yang ni berapa panjang the solidified, contoh dia berhenti sampai sini, dia dah solidified kan. So that itu adalah fluidity index. The greater the length of the solidity metal, the greater its fluidity. Maksudnya lebih banyak, lagi panjang, lagi lama dia flow. Contoh kalau dia flow dekat sini, maksudnya this molten metal adalah fluidity dia lebih tinggi daripada, contoh ini fluidity untuk A. Contoh dekat B dekat sini nanti. So that fluid molten metal untuk fluidity X, fluidity index untuk metal A adalah lebih kurang daripada fluidity index untuk metal molten metal B. This is, it means by what is the fluidity. Okay, this is the temperature distribution during the metal solidification. Okay, this is distance. This is the melting point. Okay, kalau kita tengok daripada room temperature ni, ini dalam mol lah. Bila dalam mol ni, dia akan naik multi-metal and then dia pergi pada solid dan juga dia akan pergi pada liquid kembali. Okay, temperature distribution at the interface of the mold wall and the liquid metal during the solidification of the metal in the casting. Okay. Okay, this is the solidified skin on a steel casting. Solidified skin on a steel casting, the remaining molten metal is poured out at the times indicated in the figure. Okay, ini pada 5 second. Ini pada 1 second, 2 second, 6 second. Kalau kita tengok, dia punya skin ni makin lama makin tebal. Hollow ornamental and decorative object are made by a process called flush casting which is based on this principle. Kebanyakannya objek-objek yang dekoratif kita buat by this principle lah. Solidified skin. Maksudnya kita tuangkan molten metal tu tapi bukannya untuk kita penuhkan the cavity. But then kita cuma penuhkan dia punya skin saja dekat dia punya wall, dinding je saja. Okay, this is the casting of the aluminium piston. Ni piston. Ni piston yang dah post processing lah. Maksudnya kita dah buang dia punya spur ni semua. Kita dah buang dia punya ni semua. Dan dia akan jadi macam ni. And then kita dah buat surface finish. This is the aluminium piston for internal combustion engine. This is the S-cast and then A. This is the after machining process. Okay. Yang ni dia punya simulation of mold filling and solidification lah. Okay. Dia kata A tadi 3.7 second after start pouring. And then note that the mashi zone has been established before the mold is filed completely. Using a vent untuk B yang ni Using a vent in the mold for removal and trap air 5 second after the pour. Ini adalah selepas 5 second. Okay. Yang ni adalah dia punya ni lah. Kalau nombor 6 ni maksudnya ini adalah temperature dekat sini paling tinggi. Bandingkan dengan temperature di sini. Okay. Sama juga dengan ni lah. Okay. This is ada entrap A lah dekat sini. Okay, this is the summary of the casting process. Kita ada banyak lah. Kita ada sand casting, kita ada shell mold casting, evaporative pattern plastic mold, ceramic casting, investment, permanent mold, die, centrifugal. Okay. Ini adalah dia punya advantage dan juga limitation. Okay, ini adalah jenis-jenis casting. Yang mana yang ni proses-proses ni kita akan tengok kemudian lah. Yang mana kita akan tengok centrifugal, permanent mold, investment mold, and then shell mold dan juga sand casting. Okay. Ini adalah general characteristic of the casting processes. Ini berapa dia punya labor cost, berapa weight, berapa what is the typical material to be cast. Contoh macam plaster casting, kita cuma boleh guna non-ferrous saja. Sama juga dengan die casting. Okay. But then the others casting type, we can use all type of the materials. Okay. This is the casting application and characteristics. Ini maksudnya E excellent, G good. Contoh untuk aluminium, typical application dia piston, clutch housing, intake manifold. Maksudnya dia punya cast ability, maksudnya ability untuk the cast adalah excellent. Untuk di weld, biasanya fair je lah pada aluminium. Untuk di machine, dia biasanya excellent untuk aluminium. Okay. Ini contoh. Okay, ini sambungan. Ini adalah property application of the cast iron. Ini contoh cast iron punya lah. Jenis-jenis cast iron, kita ada grey cast iron, white cast iron. Cast iron ni biasa kita buat engine block. Okay. Ini dia punya dia punya mechanical properties lah. This is the mechanical properties. Okay. Okay. Ini cost characteristic of casting. Ini adalah contoh-contoh. Ini adalah cost yang terlibat. Kalau kita tengok dekat sini, cost production rate. Kalau kita tengok production rate per piece, yang paling banyak adalah investment casting. Yang paling sedikit adalah plaster casting. Per hour kita boleh buat 10 saja. But then for investment casting per hour kita boleh buat 1,000. Okay. Okay, ini tadi just macam pengenalan saja. So baru kita nak masuk the casting process. Okay. Untuk casting process, there are two molds, which is the expandable mold dan juga the permanent mold. Mold tadi yang ni lah. Ni lah. Ni you punya mold. Okay. Ni you punya mold. Jadi apa yang dimaksudkan dengan expandable mold? The mold are typically made from the sand, plaster and ceramic mixed with various binders and bonding agent in order to improve the properties. Sand mold, ni contoh sand mold consists of 90% of sand, 7% of clay. Clay sebenarnya just untuk kita holdkan that sand. Kalau tidak kan dia berterabur. And then 3% of water. And then mold material are refractory type. Okay. And then the permanent mold pula, mold are made from metal which can maintain the strength at high temperature. Expandable mold maksudnya kita buat sekali, lepas tu kita pecahkan. Maksudnya tak boleh nak, tak boleh nak guna berulang kali lah. Kita cuma boleh buat sekali je. Maksudnya kita dah tuang the molten metal, and then kita dah solidifying, and then kita remove. Untuk kita removekan tu, kita pecahkan terus semua mold tu. Okay. Untuk yang permanent pula, kita boleh menggunakannya berulang kali. That's why dia diperbuat daripada metal. Maksudnya kita dah tuang, kita dah solidify, and then kita removekan dia. Bukan jenis kita remove pecahkan dia. Mungkin dia ada screw ke apa, terbuka. And then, kita ambil the product. Untuk guna balik, kita cantumkan balik. And then the mold can be used repeatedly. Mold design, casting can be removed easily. Metal mold are good heat conductor. Therefore, the solidification is subjected to a higher rate of cooling. Okay. Oh, kita ada yang ketiga adalah composite mold. Molds are made from two or more different metal. Sand, graphite, metal consist of both permanent and expandable. Tapi yang kita cover expandable dan juga permanent mold. Okay. Untuk expandable mold pula, untuk yang ni untuk expandable mold kita ada 3 jenis mold. Which means kita ada sand casting, investment casting dan juga loss form ataupun loss wax. Okay. So kalau kita tengok, this is the sand casting. This is the sand casting, maksudnya ni you punya this is the mold, depan ni lagi tak? Okay, ni lah. Maksudnya ni adalah sand. Kita dah siapkan you punya you punya cavity semua, and then kita masukkan sand, and then kita akan tekapkan. Okay. This is the sand casting. Sand casting, the most widely used sand casting because dia cost murah lah. Use cast process, utilize expandable sand mold to form complex metal parts that can be made of nearly any alloy because the sand mold must be destroyed in order to remove the part. Maksudnya tadi lah saya cakap, that's why dinamakan expandable mold. Kita tak boleh gunakan berulang kali. Called the casting, and sand casting typically has low production rate. Okay. The sand casting process involves the use of furnace, metal, pattern and sand mold. The metal is melt in the furnace. Molten metal tu kita dalam furnace, and then the ladle and the and pour into the cavity of the sand mold, which is formed by the pattern. The sand mold separates along a parting line, and the solidified casting can be removed. Okay. Ya, saya ada video tak? Video untuk ni. And saya tengok ada tak video sand mold. Centrifugal casting, loss form, sand casting. Okay, kita tengok video sand casting. So dia awak nampak lah dia punya ni macam mana. Mana saya dah buka ni. Okay, saya cuba tengok video sand casting jap. Wah, kuatnya. Angin. Kalau tak dengar video ni, you cakap tau. Saya tak tahu, buat saya tak boleh nak dengar. Dengar suara dia?
Tak, doktor. Tak dengar, doktor.
Rasa dia tak ada suara kot. Tak apalah, you tengok animation je. Ini adalah sand casting Dengar sand casting Pattern are made, dia kata apa? Pattern are made from the top and bottom half. Feet and riser are added to one of the pattern. Ini nama dia pattern Pattern ni adalah apa orang kata cavity mold. Cavity yang you nak letak the produk tadi. Pattern ni bukan produk Pattern ni adalah macam mana cakap dia adalah, nanti kita akan tengok slide satu lagi sebenarnya Pattern ni dia adalah sebenarnya cavity untuk mold. Bayangkanlah dia ada pattern, nanti mold yang akan awak buat adalah cavity ni lah. Itu maksud pattern Okay, and then diletaklah metal wooden sandbox are placed, and then diletakkan apa kata dia, sand tadi and then dia compactkan. Okay, dia compactkan, and then dia buka. Nampak tak? Kita ulang nampak tak? Dia letak ni, ngadang ni, and then dia letak ni. Itu adalah awak punya pattern kan. Bila dia mampatkan, selepas dia mampatkan, and then dia buka, so that, nampak tak? Ini adalah you punya cavity tadi. Cavity ni lah adalah you punya, bila kita tuang molten metal nanti, inilah produk awak sebenarnya. So that pattern tu adalah sebenarnya untuk membuat cavity for the product, for the mold. Okay. Yang ni kita panggil mold. So, bila dia rapatkan, the screw and then dia tuang molten metal. Okay, and then dia solidified lah. The metal solidified and cools, and then bila kita buka balik, bulat buka. Okay. So, terus dapat, inilah produk awak. Tapi ini awak kena buang lah nanti. Ini produk ni kena buang lah. Okay, buang, dapatlah. Ini adalah produk untuk sand casting. Okay. Okay. So, saya share balik kita punya slide tadi. Itu adalah sand casting Jadi awak nak, kalau suruh terangkan pun awak faham lah kot bila tengok video tadi kan. This is the castability of the metal. Untuk metal yang dia boleh casting adalah alloy steel, carbon steel, cast iron, stainless steel, aluminium, copper, magnesium and also the nickel. Yang feasible, yang mungkin boleh di-cast ataupun mungkin tak boleh di-cast adalah lead, tin, titanium dan juga zinc. Okay. This is the sand mold. Sand mold factors to be considered in selecting of sand for mold. Kita ada green sand, kita ada jenis-jenis mold untuk sand casting. Green sand, wall box ataupun no bake. Sand with fine round grains can be packed closely, form a smooth and mold surface. Fine grain sand enhance the mold strength and lower the mold permeability. Okay, maksudnya sand yang kita nak gunakan tu sepatutnya sand yang very fine. Tak adalah sand yang pasir yang kasar-kasar. Kalau kasar nanti dia akan banyak cavities dan juga strength tak kuat. Okay. Good permeability of the mold and core allow gases and steam evolve during the casting to escape easily. Maksudnya bila permeability ada, maksudnya kita senang membuangkan gas-gas yang ada lah. So dia tak adalah ada bubble nanti. The mold should also have a good collapsibility to allow for the casting to shrink while cooling. Okay, to avoid defects in casting such as hot shearing dan juga cracking. Okay. Ni adalah green sand. The most common use as a mold, mixture of sand, clay and also the water, least expensive in making mold. Sand is recycled easily for subsequent use, commonly used in the casting for non-ferrous, which include aluminium and brass. The term green sand is known principally because of the moisture content within the sand. Okay, ini adalah green sand. Saya tak tahu saya ada video tak? Ada. Okay, ini paling simple lah, green sand. And then this is the cold box. Various organic and inorganic binders are blended into the sand to bond the grain and the mixture harden at room temperature. Chemically, for greater strength, this kind of mold are more accurate dimensionally than the green sand mold. Ni ditambah binder. Kalau tadi ni tak ada, dia cuma ada sand, dia ada clay, dia ada water. Clay ni sebagai adhesive untuk kita untuk kita bond kan, the sand tadi. But then untuk cold box ni kita tambah binders untuk lebih lebih cepat, lebih keras dan juga lebih strength dia greater. Okay. And then this is no bake. No bake or dry sand molding use chemically bonded sand and is usually used for casting requiring intricate detail. Okay. Dry sand allows us to create a casting with a high mechanical properties and dimensional stability. Okay. Complex core package may be set into the mold to create intricate parts with stable wall thickness. So that kalau kita tengok dia punya ni, dia punya advantages dia macam ni lah. Ni low advantages, ni high advantages. Okay. Okay, so kita pergi kepada tadi distance casting, so kita pergi kepada investment casting ataupun kita panggil lost wax process. Part dimension dia adalah up to 1.5 meter in diameter and 1140 kg in weight. Investment casting derive its name from the pattern being invested. Dia dapat daripada pattern. Tadi saya cakap tadi kan, pattern adalah pattern boleh daripada kayu ke, daripada besi. So that pattern adalah untuk kita buat mold tadi, the cavity of the mold. Okay. Many materials are suitable for investment casting. Example, stainless steel, brass, aluminium, carbon, and glass. Okay. The metal is poured into the cavity in refractory material that is exact duplicate of the desired part. Due to the hardness of the refractory material used, investment casting can produce product with exceptional surface qualities, which can reduce the need for secondary machine process. Maksudnya investment casting ni kita tak perlukan post processing. Perlu mungkin sedikit sajalah untuk kita groundkan dia the surface tadi, untuk the surface finish. Okay. This is the why investment casting, design flexibility. Investment casting produce near net shape configures. Maksudnya dia boleh berbagai-bagai jenis bentuk, dia boleh bentuk yang dia nak design tu boleh fleksibel lah. And then wide range of alloys. Dia boleh many ferrous and non-ferrous alloys are routinely cast by this investment casting. And then reduction of production cost. Costly machining operation are reduced and often eliminated. No capital equipment investment is needed to produce the part in-house. Reduction of assembly of operation. Several parts can be made as one casting, reducing handling, assembly, and inspection. Maksudnya, that's why ini berkait rapat dengan tadi lah. Ini. Maksudnya, kita boleh cast produk yang kompleks. Okay? And then the production of fine detail, spline, hole, bosses, lettering. Ini pun berkaitan dengan design flexibility. And then consistency of the component. Since cast components are produced by using wax pattern from a single tool, dimensional accuracy is the same from part to part year after year. When the design changes are required, it is usually possible to alter existing tooling at a relative minor cost. Maksudnya dia ini adalah berkaitan dengan near shape process tadi. Inilah. Maksudnya apa yang you design dia sama saja dengan apa yang you casting. Ini adalah proses untuk investment casting proses. Ya, ada video tak? Ada. Nanti kita tengok. Okay, ini adalah proses dia lah. Mold to make the pattern. Ini adalah mold untuk make pattern tadi. Pattern tu pun sebenarnya kita buat molding juga. Okay. Injection wax or plastic pattern and then this is the this is the pattern yang kita buat and then kita eject the pattern so that dapatlah dalam bentuk wax pattern yang ni and then this pattern ni kita assemblekan as a tree kita assemblekan as a tree and then kita buat slurry coating and then kita buat stucco coating. Okay, after that bila dah jadi macam ni, dah lepas slurry dan juga stucco coating dah jadi macam ni and then the pattern melt out. Maksudnya kita masukkan this completed mold tadi, awak dapat bayang tak, masukkan ni ke dalam autoclave atau ataupun dengan kata lain furnace lah. Bila kita masukkan dalam furnace sebab dia wax tadi, so that dengan suhu furnace yang tinggi tadi, wax ni akan cair. Okay, bila wax ni cair, so that dalam ni akan ada cavity lah, kan? Bila ada cavity, so that bila ada cavity kita tuangkan molten metal and then kita shake out and then keluarlah ini yang bentuk yang kita nak, produk yang kita nak. Ini adalah pattern tadi lah. Okay, this is the schematic illustration lah, how to make the investment casting. Okay, the pattern are made from wax or plastic polystyrene. The wax can be recovered and reused. The pattern can be produced by machining process or rapid prototyping. Ini tadi, ini adalah pattern yang kita buat tadi lah. Ini semua pattern. Inilah contoh tadi. Investment casting ini adalah tree. Ni yang sini. Okay, ini adalah pattern. Okay. Okay. What is the slurry coating? Okay, ini tadi. Okay, the slurry coating is the tree is merged into a slurry of refractory material. Slurry coating ni dia punya material adalah daripada refractory material and then draining to create a uniform surface coating to preserve fine detail from the mold. Silica and binder including water, ethyl and acid. Ini adalah material for the slurry. And then the stucco coating pula or render is a material made of aggregate, binder and water, cause ceramic particle. Yang ni tadi fine. Tapi yang ni lepas tu kita salutkan lagi dengan cause biasanya stucco ni adalah daripada ceramik lah. Inilah jenis stucco yang white fused alumina, white fused malai and andalusite. Okay, stucco ni the material dia adalah ceramik. Badan untuk slurry ni dia punya material dia adalah apa tadi kita panggil refractory material. Okay, hardening allow coating to cure. This step are repeatedly until investment reach its required thickness. Usually 5 ke 15 mm. Okay, thickness. Once when the coating is dry and solidified, the pattern will continue with the coating process to increase the thickness and the strength. Okay. Inilah, ni tadi sebenarnya apa yang saya cerita tadi Bila dah kering ni and then kita masukkan dia dalam furnace ataupun autoclave pada suhu 90 ke 175. This process will take place until 12 hours in order to melt out the wax. Again, the mold will be heated to 6,500 to 1,500 to 10,500 in 4 hours to eliminate the water of crystallization and residual wax if any. Okay. And then once dah semua dah ada ni, kita masukkan molten metal, the solidify and then dapatlah casting. Okay. Ni you boleh tengok dekat YouTube lah. Cara-cara untuk casting. Okay. Okay, cuba kita tengok video ni sekejap. Sebelum kita rehat, kita tengok video ni. Lagi berapa slide? Okay, sikit lagi. Tak ada lah, tak ada. Silap. Tak ada video. Tapi daripada sini you dah dapat idea macam mana dia buat. And then this is the automated shell production. Nak buat shell tadi A robot generate a ceramic shell on wax pattern. Dia sama juga ni adalah one of the investment casting The robot is programmed to dip the trees and then place them in automated drying system. With many layers, a thick ceramic shell suitable for investment casting is formed. Okay, ini adalah automated shell production. Okay, this is a large form casting. Last untuk ni. Cuba kita lihat. Use a mole of sand packed around a polystyrene foam pattern which vaporize when molten metal is poured into the mold. Okay? And then other names are lost form process, lost pattern process, evaporative form process, and full mold process. Polystyrene form pattern is include the sprue riser getting system. Mold does not have to be opened into the scoop and drag section. Okay, ni contoh dia lah. Ini kita punya apa dia berbeza sikit dengan ni tadi dengan apa investment casting tadi. Ini adalah lost form. Kita ada styrofoam. This is styrofoam pattern. And then kita masukkan dalam ni, dan kita ada support by inilah support by the sand. And then this styrofoam ni bila kita tuang macam ni, kita tuang terus molten metal. Bila kita tuang molten metal ni, this styrofoam ni disebabkan oleh molten metal punya high temperature. This styrofoam ni akan evaporate dengan sendirinya. So dia bila dia evaporate, dia akan ada cavity lah dekat sand mold ni tadi. Dia sebenarnya macam sand casting juga. Dia akan ada cavity, so dia akan fill in the cavity ni lah untuk jadikan dia produk. Okay. This is apa orang kata lost form. Lost form ni macam sand casting juga. Okay. Dia tak sama dengan yang tadi investment casting. Investment casting tadi dia macam ni. Kita buangkan siap-siap. Maksudnya dah ada dia punya cavity baru kita tuang. Tapi yang ni tanpa cavity. Untuk lost form ni dia tak ada cavity pun. Kita terus tuang. Okay. This is the process lah. Ni contoh dia. This is molten molding. Biasanya untuk yang apa lost form ni kita punya pattern ni diperbuat daripada polystyrene ataupun polimer. Sebab molten metal tu kan tinggi. Dia punya suhu tu kan. Ni contoh dia. Ni dimasukkan dalam ni, coatingkan, compact. Ni semua contoh adalah casting lah. Okay, lost form casting. Okay, ni pun contoh lost form casting. Okay, kita tengok video sebelum kita rehat. Untuk lost form casting Okay, dengar suara tak? Suara dia dengar tak?
Tak.
Okay, tak ada suara tu kot.
Dengar doktor.
Lah. Dia ada suara tak? Ada suara tak? Tak ada
Ada suara
lah,
doktor.
awak
Tak ada
ada?
doktor. Tak ada.
Tak. Okay, tak ada tak apa. Awak tengok gambar je lah. Saya pun tak tahu macam nak bersuara dengan dia. Oh, patutlah tak ada suara. Sekejap. Saya tahu. Share. Okay, baru ada.
Contain a gas or blowing
Ini ada suara kan?
usually tin gas or blowing
Ada doktor ada.
usually tin
First,
gas.
the
innovative metal casting process of the future has been slow to develop, but is finally a technical and commercial success. The name Lost Foam refers to the process of creating a foam model of the casting and then replacing the foam with molten metal. The process begins with polymer beads, which must be expanded to a controlled low density for molding. The beads, as purchased, have a cellular structure and contain a gas or blowing agent, usually tin tans. In a pre-expander, steam is used to heat the beads, softening the polymer and expanding the gas. Control of density and bead distribution is critical in this operation. After pre-expansion, the beads must be stored for stabilization before use in molding. A distribution system delivers beads from storage to the molding machine. Tooling mounted in a molding machine provides a cavity in the shape of the casting or a portion of the casting. The preheated cavity is completely filled with beads from fill guns. Steam is again used for heat. Now enters the cavity through vents and further heats the tool from the back side. This causes the beads to expand into the void. And
tapi di dalam Inggeris ke dalam apa Sebab saya tak boleh dengar lah. Tapi di dalam Inggeris dalam apa
water and vacuum to allow the foam to be removed from the tool. Tooling is pre-machined polished aluminum using very precise dimensions and an unusual but smooth surface finish with precise detail. The tooling is exposed to only non-abrasive beads and steam temperatures, and usually maintains surface finish and original dimensional accuracy throughout an extremely long life. Foams are normally aged, usually in a controlled warm air oven, to stabilize the dimensions. Foams can be molded in one piece, sometimes using movable pulls. Multiple pieces can be glued together to form extremely complex parts with internal passages and details sometimes not feasible in other processes. Gluing is normally done with special hot melt glue printed on the parting line between foam slices. Excellent dimensional tolerances, appearance and casting quality can be achieved when flat glue lines are properly designed and when tooling and equipment have proper precision and control. Foam replicas are then assembled with a gating system to form a cluster of parts to be produced in one flask. This can be done manually or by machine. Foams or clusters are then dipped in a water-based refractory coating which covers all surfaces of the foam, including internal passages. The coating will now have an internal surface equal to the outside surface of the foam. The wet, coated foam cluster is then placed in a drying oven to remove the water. Ideal process control and throughput are achieved with dehumidification and internal humidity control. The coated dried cluster is placed in a special steel flask, either manually or automatically. Dry sand with no additives is then rained around the cluster, and vibration is applied to the flask. Inside, the vibration of the flask causes a layer of sand near the surface to fluidize. In this layer, the sand flows around and into the inside passages of the foam. The sand level rises as additional sand is rained in. Below the fluidized layer, the weight of sand above, together with vibration, causes the sand grains to move closer together, compacting. The vibration and the flowability of dry sand causes densities of the compacted sand around the coated foam to be 10 to 15% higher than in other sand processes. Proper control of vibration and sand fill can ensure low foam distortion and full rigid backing of the coating. Some systems use synthetic molite in place of sand to further improve cycle times and dimensional tolerance. After fill and compaction, molten metal is poured into the cluster. As the liquid metal moves inside the coating, the heat energy causes the foam to liquefy, evaporate, and break down chemicals. The temperature of the metal poured and the foam characteristics will determine how much liquid, vapor, and gas will be formed. Special coatings have now been developed for various types of castings, which have capillary action to absorb liquids, as well as permeability to allow passage of vapors and gases. Because there is nothing in the sand to burn out, creating collapse or mold wall movement, dimensions are very accurate. After the poured cluster is allowed to solidify, the flask can be simply tipped over. The unbonded sand flows out. No additional violent shakeout or core removal are necessary. Because the foam pattern is left in the mold, no parting line is needed. This allows orientation of the casting to be more flexible and permits clustering, which produces more parts in a given mold area. More parts per mold means higher production at slower molds per hour rates. The dry, unbonded sand is easily recycled with minimum energy consumption. The mass of foam is low compared to the binders burned out in other sand processes, reducing emissions. This makes lost foam an energy and environmentally friendly process because there are no cores, core defects, and fins are eliminated.
Doktor tak dengar. Doctor of mic.
Okay, jadi kita rehat sekejap untuk 5 minit, and then 3-5 minit nanti you all buka ULearn and then jawab dekat yang week 4 You look at week 4 tu and then you jawab quiz lah. Saya bagi masa dalam start 3-5 minit sampai 3 suku. Okay. So kita lihat sebentar.
Okay, doktor.
Sementara tu saya share yang QR code tadi Yang mana tak sempat tu. 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 Okay, semua dah boleh buka YouLearn and then jawab quiz sekarang. Semua dah boleh buka YouLearn and then jawab quiz sekarang. Semua dah boleh buka YouLearn and then jawab quiz sekarang. Semua dah boleh buka YouLearn and then jawab quiz sekarang. Semua dah boleh buka YouLearn and then jawab quiz sekarang. Semua dah boleh buka YouLearn and then jawab quiz sekarang. Semua dah boleh buka YouLearn and then jawab quiz sekarang. Semua dah boleh buka YouLearn and then jawab quiz sekarang. Semua dah boleh buka YouLearn and then jawab quiz sekarang. Semua dah boleh buka YouLearn and then jawab quiz sekarang. Semua dah boleh buka YouLearn and then jawab 5 minit lagi Okay, masa kuis dah tamat. So, saya akan sambung. Kita akan sambung sikit lagi Okay, masa kuis dah tamat. Okay, kita sambung kepada permanent molar casting lagi Okay, masa kuis dah tamat. Ini dari 3. Jadi, kita sambung kepada permanent molar casting. Okay, masa kuis dah tamat. Ini dari 3. Jadi, kita sambung permanent molar casting. Hard mole casting, echo mole casting, echo mole casting. Oh, share your computer audio, betul lah. Okay. So permanent mold casting consists of two half of mold made from material with high resistance to erosion and thermal fatigue. For example, the cast iron, steel, bronze, graphite, refractory metal, alloy. Maksud dia consists of two half mold, maksudnya ni yang ni lah. Kita ada two half mold. Okay. And then the mold cavity and getting system are machined into the mold. Sometimes core tadi untuk buat core mana tadi core tadi core tadi untuk buat lubang core and insert are integrated to produce casting with interval cavities. Maksudnya untuk kita buat lubang lah core dan juga insert. Typical core material are all bonded or resin bonded sand, plaster, graphite, gray iron, most commonly used, and particularly for large molds for aluminium and magnesium casting, low carbon steel and hot work die steel. This is the material, the common material for the core and insert. Okay, to ensure the permanent mold become long-lasting, the surface of the mold cavity are usually coated with refractory slurry, sodium, silicate, and clay. Okay, and then or spray with graphite after every few casting process has been done. Okay, the coating also act as a parting agent as well as controlling the cooling rate of the casting. Certain process need to have mechanical injectors to push the casting once it is solidified. Ada yang tak boleh kita nak remove. So that kita kena ada certain mechanical injector lah. Okay. Ini secara basic, secara penggata what is permanent mold casting is. Okay. Okay, untuk permanent mold casting ni kita ada tiga lah, die casting, centrifugal casting dan juga vacuum casting. So kita tengok what is the die casting. Typically parts which made from this process adalah motor housing, engine block, appliance components, hand tools, toys, etc. lah. Equipment costs are very costly, especially the dies. Concept of the process, the molten metal is forced into the die cavity at pressure ranging from 0.7 to 700 megapascal. In die casting, there are two basic types of machine. Untuk casting, untuk die casting kita ada dua, satu hot chamber die casting and then satu lagi cold chamber die casting. Ini adalah permanent casting. Okay, this is the the illustration of the hot chamber die casting. Okay, kalau kita tengok dia lebih kepada macam horizontal lah. Okay, this is the hydraulic slot shot ni. Kita hydraulic kan dia, kita pump bagi dia tekanan and then kita punya molten metal akan masuk lah dalam kita punya cavity ni. Ini die ni ejector die ni untuk untuk masa nak remove the mold nantilah. In this process, a piston will trap a certain volume of molten metal and force it into the flows into the cavity through a goose neck and nozzle. Okay, this is the goose neck. Dia through the nozzle lah. Ni plunger lah, plunger untuk tekan and then this is the nozzle. This is the molten metal lah. Bila kita tekan hydraulic ni, dia akan masuk lah molten metal ke dalam ni. Pressure supply can goes up to 35 megapascal. The molten metal is held under the pressure until it solidified in the die cavity. Maksudnya molten metal ni akan continuous dalam pressure ni lah, dalam pressure hydraulic cylinder ni tadi, dalam pressure sehingga kita punya sehingga molten metal ni akan solidified lah dalam this die cavity. There is a circulating water or oil through the various passageways in the die block to assist in rapid metal cooling as well as to improve the die life. Okay, ni yang sebenarnya lah die casting. Material that can be used to cast by using this process are those material which have low melting point alloys such as the zinc, magnesium, tin and also the lead. Ni adalah hot chamber. Okay. Dia jadi hot tu sebab apa? Sebab dia ada, nampak ni, dia ada furnace kat bawah ni. Maksudnya molten metal ni kita melt dia terus. Okay. This is the cold chamber. Okay. The cold chamber pula, apa beza dia? Ya, of course lah, dia punya proses dia ada dalam keadaan suhu bilik. Molten metal is poured into the injection cylinder. The chamber is not heated. Yang tadi chamber tadi heated. Okay. Ni chamber ni kita heat. Tapi yang ni kita tak heat. Okay, this chamber kita tak heat. The chamber is not heated. There is That's why this process is known as a cold chamber. The molten metal is forced into the die cavity with pressure 20 to 70. Maksudnya the pressure is lower than the hot chamber tadi. Material that can be used to cast by using this method are those materials which have the high melting point alloy such as the aluminium and also the copper. That's why kita menggunakan dia cold chamber. Sebab material yang dia boleh dicast adalah yang high melting point. Kalau high melting point maksudnya kita apa kata dia punya material tadi, dia punya metal tadi kita akan heat berasingan. Lepas tu baru kita tuangkan ke dalam die casting process. Dia berbeza dengan hot casting tadi. Hot casting tadi kita boleh heat dalam chamber ni itself. Sebab apa? Sebab dia punya molten metal ni adalah low melting point. Maksudnya sebab furnace ni pun dia ada certain temperature lah. Maksudnya kita tak boleh nak untuk yang high temperature punya alloy kita tak boleh nak guna hot chamber. Sebab furnace ni ada certain temperature. That's why kalau high melting point punya metal kita menggunakan cold chamber die process. Okay. Ini adalah various type of cavity in the die casting die. Ni boleh tengok lah. This is the single cavity die, multiple cavity die. This is the combination and also the unit die. Okay. Ini contoh. This is the properties and application of die casting alloy. Ini nanti you baca sendiri. Okay. So, saya nak tunjuk video untuk yang die casting. Jadi awak akan lebih faham lah. Kita tengok yang hot chamber die casting dulu. Okey, 1 minit je dia punya ni. Okey, kita tengok dulu Sekejap. Kalau tak dengar bagi tahu Ataupun kalau echo bagi tahu
Hot chamber machines are used primarily for zinc, copper, magnesium, lead, and other low melting point alloys that do not readily attack and erode metal pots, cylinders, and plungers. The injection mechanism of a hot chamber machine is immersed in a molten Hot chamber machines are used primarily for zinc, copper, magnesium, lead, and other low melting point alloys that do not readily attack and erode metal pots, cylinders, and plungers. The injection mechanism of a hot chamber machine is immersed in the molten metal bath of a metal holding furnace. The furnace is attached to the machine by a metal feed system called a gooseneck. As the injection cylinder plunger rises, a port in the injection cylinder opens, allowing molten metal to fill the cylinder. As the plunger moves downward, it seals the port and forces molten metal through the gooseneck and nozzle into the die cavity. After the metal has solidified in the die cavity, the plunger is withdrawn, the die opens, and the casting is ejected.
Okay, yang tu adalah hot chamber, hot die casting. So kita tengok yang cold die casting lah. Okay, yang tu adalah hot chamber, hot die casting. Kita tengok yang cold die casting lah.
Cold chamber machines are used for alloys such as aluminum and other alloys with high melting points. The molten metal is poured into a cold chamber or cylindrical sleeve, manually by a hand ladle or by an automatic ladle. A hydraulically operated plunger seals the cold chamber port and forces metal into the locked die at high pressures.
Okay, tadi you dah tengok die casting hot dengan cold chamber So harapnya faham lah bila tengok video tu tadi. Okay, so next adalah centrifugal casting. Okay. Okay, untuk centrifugal casting, utilize the initial force which caused by rotation to distribute the molten metal into the mold cavity. Yang tadi dalam die casting tadi kita dia menggunakan pressure maksudnya kita pour and then kita tekan and then dia terus masuk dalam cavity. Maksudnya for the centrifugal casting, nama pun centrifugal maksudnya sambil kita tuang tu dia akan ada rotation, dia berpusing. Okay. Untuk centrifugal casting, they are involved with 3 types. True centrifugal, semi-centrifugal dan juga centrifuging. Okay. This is the true centrifugal casting. Kalau awak tengok contoh dalam ni, dia tuang, this is the mold, sambil dia tuang ni dia akan rotate. This dry shaft and roller ni akan rotate lah. Akan rotate that mold. Figure show the schematic illustration of the centrifugal casting process. Pipe, cylinder, liners and similarly shaped parts can be cast with this process. Untuk centrifugal casting ni lebih kepada nak buat pipe. Maksudnya yang ada hollow tadi. Maksudnya yang hollow tapi yang continuous. Contoh kalau katalah hollow tak continuous, just one part je, kita boleh buat just sand casting menggunakan kita letak mandrel ke ataupun kita letak the core ataupun core ke macam ni. Tapi kalau macam continuous untuk buat pipe lebih sesuai adalah through centrifugal casting. Okay. Casting with good quality and dimensional accuracy. Okay. And then the axis of rotation usually horizontal. Dia horizontal depending on the size of the product they produce, ranging from 13 to 3 mm diameter can go up to 16 meter long. Maksudnya panjang lah. Thickness ranging from 6 to 1 to 5 mm. Okay. Molds material are usually a steel, iron, graphite which coated with refractory lining in order to increase the mold life. The mold surface can be shaped depending on the product which goes to produce. The internal surface of the casting remains cylindrical because the molten metal is distributed uniformly by the centrifugal force. So dia berpusing by centrifugal force, so that tinggilah dia punya tu dapat video saya Ibu nampak. Okay. Okay, this is the semi centrifugal casting lah. Kalau tadi true centrifugal casting adalah dia rotate horizontal. But then the semi-centrifugal casting, they rotate vertical. Sama juga lah, the konsep dia cuma dia rotate vertical saja. Yang tadi dia rotate horizontal. Okay. This kind of process can be used to cast part with rotational symmetry, such as the wheel with spokes. Maksudnya nak buat wheel. Okay. The molten metal is poured into the pouring basin which is located on the top of the mold cavity. This is the pouring yang tadi kita masukkan macam ni. Yang ni kita masukkan daripada atas. Okay. Untuk kita buat, yang tadi kita nak buat lebih kepada pipe. Tapi untuk vertical centrifugal nak buat wheel yang bentuk simetri. Okay. The molten metal will flow through the gating system and further flows into the mold cavity, and this is done by centrifugal force. Okay, this is the schematic diagram, schematic illustration of the semi-centrifugal casting process. Okay. Ulang lagi True centrifugal adalah horizontal, semi-centrifugal adalah vertical centrifugal, and then last but not least adalah centrifuging casting ataupun spin casting. Kalau tengok dia sama lebih kurang dengan semi-centrifugal casting ataupun vertical casting. But then dia ada apa? Yang tadi ni dia berpusing. Inilah you punya ni tadi kan you punya cast material. But then yang ni tadi dia berpusing tapi you punya cast material adalah di hujung dan hujung, bukan di tengah. Yang tadi semi-centrifugal tadi dekat sini kan. Terus masuk ke dalam you punya casting product. But then untuk yang spin casting dia masuk tapi dia pergi pada hujung untuk you punya casting product tadi ada di tepi. Okay. In this process, the mold cavity are located at a certain distance from the axis of the rotation. Macam yang tadi semi-centrifugal, the mold cavity betul-betul berada di bawah ni tadi kan. Dia berada di bawah centrifugal force. The molten metal is poured from the top center. The flow of the molten metal is forced into the mold cavity by centrifugal force. This is a schematic illustration of the casting by centrifuging. The mold are placed in the periphery of the machine and the molten metal is forced into the mold by centrifugal force. Okay. So, saya nak tunjuk untuk yang video centrifugal casting. Video ni memang tak ada suara Okay, kita tengok video satu lagi. Horizontal.
Centrifugal casting is a process that delivers components of high material soundness. As a result, it is the technology of choice for applications like jet engine compressor cases, petrochemical furnace tubes, and many military products, and other high reliability applications. In the centrifugal casting process, molten metal is poured into a preheated spinning die. The die can be spinning either on a vertical or horizontal axis, depending on the configuration of the desired part. Due to centrifugal force, the more dense molten metal is pushed to the wall of the spinning die. Directional solidification of sound metal progresses from outside toward the bore, while the less dense material, including impurities, floats to the ID. Once the casting has solidified, it is removed from the die and impurities are machined away, resulting in a defect-free structure without cavities or gas pockets. To learn more about the centrifugal casting process, or to determine if it's a good fit for your application, give us a call or go to metaltech.com. Metaltech International, because you demand.
G'day everyone, Viv here. Fourth time trying to film this introduction, so we're going to keep it short and simple. Otherwise I end up not being able to talk, or the phone rings, or something else happens. Right, time to spin up some moulds. I've been spinning some moulds for the last week or so. Nothing I can use at them or sell at the moment. They're just copies basically of existing figures that I've been moulding for learning basically. Learning how to make moulds, learning how to spin them, learning how to dial the pressures in on the spin caster, the speed and all that sort of stuff. The temperature of the metal, how to pour those. Each of these ingots probably weighs maybe 5 kilos. It's sitting at 318 degrees. That's a little hot. It should have switched off by now. It does sound like it's off. It should be at 287. So it overheats a little bit, then the gas switches off, and then it cools down and then switches back on and overshoots that temperature a little bit. It's not 100% perfect. Now if we have a look in here, this white metal kind of looks a little bit gunky, but if we clear this top surface away, that slag on the top, it's actually really clean. So I need to clean off that slag. It needs to be done periodically. It's just a matter of scooping off this top layer of gunky crap, but I'll do that later on. So we'll just tip that back in there. So then the spin caster, this has several settings on it. How long the mould spins for, anywhere up to 3 minutes. The pressure dictates this locking plate locks in place, and the pressure in between the mould is relevant in terms of these little gates and the vents and stuff. And if the pressure is too much, the vents get squashed and your figures get sort of what's the word? Squished, not correctly. So I'm going to spin this mould a couple of times and we'll have a look at the figures that come out. Okay, so basically the process starts with our 2 mould halves. We just need to dust it with this fine talcum powder kind of material. Line up our 2 mould halves, which we can see that little V, and when we line it up it'll lock into place. Then this needs to go on the spin caster. So then this goes into the bottom of the caster. Make sure everything's still lined up. There's little locking nugs in the bottom here to make sure it's in the middle. Locking plate goes on and it just twists it into shape. So this is set, as I might have mentioned before, to spin for half a minute at 600 revolutions per minute under 20 pounds of pressure. As soon as I close the lid here, this will lift up, and as soon as it's closed all the way, it'll start spinning. So we'll grab some metal over here from the furnace. We'll close this. That lifts up. Pour in a little bit of metal. This will spin for 30 seconds and then stop. It'll drop back down and take off the locking plate. Then the mould can come out and onto the workbench for demoulding. So here's the mould. This is a little bit cold, so I wouldn't be surprised if everything doesn't come out. There we go. We can see that the mould's not complete Because it is cold, it'll take a couple of spins for the mold to come up to temperature, and then it's just a matter of popping these out. You clear this all off. All of this will go back into the furnace and melt down, and we'll retap this and pop it back in the mold again. So this time, hopefully, we've got a full mold. There is one small little problem down the corner here. I don't know if you can see it. This figure here is missing a part of its base. So I'll cut another vent in there and that should help with that one. But otherwise, I can actually commercially. But I'm just chatting at the moment with sculptors and justers of in months. Some things.
Okay, so kita dah tengok tadi centrifugal, semi-centrifugal dan juga spin. Dan juga spin casting. Okay. Okay, this is the vacuum casting. Also known as a counter-gravity low pressure process suitable for product with thin wall, complex shape with uniform properties. Okay. Ini contohlah. Yang ni kita punya ni gate, ni you punya mold, yang ni dia punya molten metal. Maksudnya you press and then akan ada vacuum lah. Jadi bila ada vacuum dekat sini, so that dekat sini dia akan tarik lah. Maksudnya dia akan apa kata molten metal ni akan masuk by tekanan. Sebab tekanan kat sini adalah tinggi. Bila kat sini adalah vacuum. Bila kita vacuum dengan dia, so that tekanan tinggi sini akan masuk dalam molten metal. That's why kita panggil dia vacuum casting. Okay. Mixture, fine sand and urethane is molded over metal die and cured with amide vapor. Next, with the assistance of robotic arm, the mold will be immersed partially into the molten metal in an induction furnace. The vacuum reduces the air pressure inside the mold to 2/3 of the atmospheric pressure. This phenomena will allow the molten metal flow into the mold cavity through a gate which is located at the bottom of the mold. Ni yang tadi saya cakap lah. Dia akan masuk ke sini disebabkan dia ada vacuum. When the molten metal has been solidified, within a very short time, the casting can be removed from the mold. Material which can be cast for this type of vacuum is carbon, low and high alloy steel, and also the stainless steel. Okay. Okay, this is the type of the shrinkage lah. Shrinkage which cause dimensional changes and sometimes cracking is the result of the following three sequential events. Contraction of the molten metal as it's cooled prior to solidify, and then contraction of the metal during phase change from liquid to solid, during the solidification, following the phase changes during the liquid and solid, dia akan ada shrinkage, and then the contraction of the solidified metal, the casting as its temperature drop to ambient temperature. Okay, maksudnya shrinkage ni boleh berlaku di sini, di solidification, okay, di sini, during di sini, dan juga apa kata during the temperature drop to the ambient temperature lah, okay. And then the largest potential amount shrinkage occur during the cooling of the casting to ambient temperature. The largest shrinkage berlaku di ini. Okay. Maksudnya solidification tu boleh berlaku di sini, boleh berlaku di sini dan juga boleh berlaku di sini. Tapi the most shrinkage occur at this facet, antara B ke room, antara solidification temperature until the room temperature. Okay. This is the avoiding shrinkage cavities lah, untuk kita avoidkan shrinkage cavities tadi. Kita punya design riser, apa dia punya design riser dia ni? Ini dia punya apa kata, dia punya yang ni adalah good maksudnya yang ni fillet kan. Maksudnya dia tak bentuk sangat fillet lah, kita ada bentuk yang macam ni instead of bentuk yang macam ni. And then dia punya ini pun sama. Ini adalah design riser untuk kita avoidkan shrinkage. Instead of kita buat macam ni, dia punya riser ni kita buat macam ni. Sama juga dengan yang ni. Kita buat macam ni lah. Okay. So kita avoidkan dia punya shrinkage cavity tadi. Okay. Ini adalah defect-defect dalam sand casting process. Kita ada hot tear. The defect occur because of the casting cannot shrink freely during the cooling, owing to constraint in various portion of the mold and core. Okay. Ini adalah contoh hot tear. Hot tear ni biasanya berlaku sama ada di hujung-hujung ni ataupun di tengah-tengah ni. Okay. And then kita ada caused by trap of the gases. That's why tadi kita menggunakan apa tadi? Saya ingat untuk kita eliminate kan gases tadi. Kalau ada gases, dia akan defect, dia akan trap lah. Jadi bila dia trap, dia akan jadi macam ni lah. Dia ada blister, dia ada scar, dia ada scab. And then porosity, it caused by shrinkage of gas. Sometimes it can be both. And this defect can be reduced or eliminated by adequate liquid metal should be provided. Maksudnya, macam tadi yang you tengok video yang spin centrifugal tadi kan, bila tak cukup dia punya molten metal tu, maksudnya nanti tak habis lah you punya tak fill in lah dia punya cavity tadi, mold cavity tadi, so that tak cukup lah you punya ni. And then kita ada internal or external chilling. Okay. And then this is the defect in metal casting process. There are 7 basic categories of casting defects have been classified as developed by the International Committee of Foundry Technical Association as a standard nomenclature. Okay, kita ada metallic projection, cavities, ni nanti you baca sendiri lah discontinuities, defective surface, incomplete casting, incorrect dimension of shape, and also the inclusion. Okay. Ini metal casting, design material economic. Ini contoh ni adalah design rules lah untuk casting. Use ready or fillet to avoid corners. Ini pula deep cavity should be on one side of the casting where possible. Ini contohnya ni. Okay. Ini good. Ini adalah poor. Okay. And then wall section should be uniform. And then ribs and or fillet improved bosses. Looping bosses can be designed for straight die parting to simplify the die design. Okay, and then side cost can be eliminated with this whole design. Okay, ini pula elimination of hot spot. Example of design showing the importance of maintaining the uniform cross section in casting to avoid hot spot and shrinkage cavities. Okay, jadi lah instead of kita buat macam ni, dia ada bentuk ni kan tajam ni, kita buat bentuk ni fillet ni. Okay, dia ada ready fillet lah. Okay, ini good and poor design. Ni contoh example undesirable, poor and desirable casting design. Ni adalah poor, ni adalah contoh yang good. Okay, ini contoh dia lah, nanti tengoklah. Poor dan juga good. Okay. Okay. Video tak? Sekejap. Ini vacuum titanium invite casting mesh for example. Okay, tak ada video dah. Okay, setakat ni saja buat kita punya kelas pun sampai 4.50, 3.50 So apa ni? Doktor ada problem internet untuk jawab kes. Okay, so minggu depan kita akan masuk yang still chapter 3, 3C, and then kita akan masuk chapter 4 lah. So siapa yang tak boleh jawab quiz tadi? Muhammad Arif ada problem internet. Dia ada dalam ni tak, Muhammad Arif? Ada? Muhammad Arif Zainuddin. Okay kan? Ya, Dr. Muhammad Arif ada problem internet. Ada je ni Muhammad Arif? Siapa yang tak boleh jawab? Ada yang tak ada jawab internet tak tadi? Tak boleh jawab internet. Jawab quiz tak tadi? Arif ke tak boleh? Hello, dengar tak? Oh, dah boleh dah. Okeylah, kalau dah boleh, okeylah. Okey. Okey, so kita akan berjumpa minggu depan lah. Saya punya tekak pun dah sakit. Okay, thank you very much.
Terima kasih, Doktor.
Thank you, Doktor.
Thank you, Doktor.
Terima kasih, Doktor.
Thank you, Doktor.
Doktor.
Thank you, Doktor.